So what we're excited about for KubeCon this year is the launch of a new approach to observability we call AI-guided troubleshooting, something we've been working on for a few years, and it's our approach for how, in a world of AI, developers should go leverage the power of AI to go debug and root cause issues. And I would say there's three components to the foundation of this, and then three features we're releasing on top. For the core foundation of it, I would say the thing that powers this at its core is a temporal knowledge graph. It's a knowledge graph that has all of your applications, your infrastructure, and it's all connected together in terms of observability data, plus also events like deployments, feature flag changes, and anything else that would change to your system, because those are often related. And I'll say what's unique about our knowledge graph is two things. One, it does encompass all types of custom data sources. So in observability, most of the known data sources are from like known integrations, and every proprietary agent will have a set of integrations it comes with. But what's interesting about observability is most of the observability data for an organization is custom. It's in custom instrumentation. And most of the other tools out there cannot understand and incorporate this custom instrumentation into their knowledge graphs or into their products, but we do. And you can imagine in incorporating a lot of that, we have to normalize a lot and scrub a lot of the data here, right? So to give you an example, when it's custom instrumentation, the developer has control in naming everything, naming the metrics and naming the label values. So to give you an example, one developer may be referring to a data center as DC, and they may be using underscores in the values there. And another team may be using Cloud AZ as the name, and they may be using dot-separated nomenclature in the values there, right? So you can imagine in building this knowledge graph, we actually have to spend a lot of time and we provide a lot of features and tools to go and actually normalize all that data so that both the developers can refer to the data that they instrumented themselves in their own way, but it's also at the same time connected on the back end, thus that we can build a complete knowledge graph there. So those are two of the components on the foundational layer there. And then layered on top of that is, not only do we want to use the knowledge graph to figure out what the dependencies are and where the causations of issues are, but often the issues are pretty nuanced. But you can imagine it's pretty easy to detect an issue where a whole service is down or a whole AZ is down. It's much harder to detect an issue where only a subset of users are impacted, or perhaps only one particular build version is impacted. And for that, it's not just looking at which components of the knowledge graph are broken, but how the flows through that knowledge graph are. So we do also use our analytical features, things that we've been working on for years, like a DDX, like a differential diagnosis, to go into the nuanced view of the requests through the knowledge graph and detect issues there. So those are the foundational pieces that we've been building. On top of that, what it looks like for the end user is essentially, the first thing is suggestions. So instead of logging into the system now and looking for the dashboard and looking for a spike on a dashboard and asking us to analyze it for you, we do that behind the scenes for you automatically. So when you log in and you get alerted, we've gone into the knowledge graph and we've applied all of our analytical features like DDX on the data and essentially suggested to you or figured out what are potential issues or root causes of issues and suggest those to you in a ranked order.
Is getting implemented in the product, folks can really build confidence and see exactly what it is behind the scenes that's happening. And so the AI-guided troubleshooting and the suggestions piece is really, here's where you should start your investigating. It's replicating how the very best developers approach a problem, which is, I have hypotheses about what might be going wrong. Let's expose those hypotheses. And then you're only ever one click away from seeing all of the underlying data to understand where this is coming from, build trust in the system, and ultimately at the end, validate, yes, this hypothesis was worthwhile, and let's capture that and feed it back into the temporal knowledge graph for future incidents. So it's sort of cyclical system in terms of validating along the way, putting users in the driver's seat and really helping them see and build trust in the system as they go through the process.